Hello everyone, I am Shivani and welcome to Civil Series. First question, in India, yellow and white color on milestone indicates. So for different kind of highway, different colors are given to milestone. So for national highways, the color is yellow and white. So here first option is correct. But for remaining highways, the colors are for state highway the color is green and white. For village road the color is orange and white. For city or the main district road the color is blue, black and white strips. Okay, so here for national highway the color is yellow and white. The next question. Then question number 2. The total width of road is 10 meter and camber is 2%. Find the height of crown of road. Okay, so this is the diagram for the height of crown. So h is the height of crown and here the h is equals to w by 2n. W is the width of the road and n is the cross slope or the camber. Here the camber is given which is 2%. So 1 by n is equals to 2%. So 100 by 2 is equals to 50. So take 1 by n value or n value as 50. Then h is equals to 10 divided by 2 into 50. The height of crown is 0.1 meter here. So option number D is correct. The height of crown of road is 0.1 meter. Third question. What will be the ruling minimum radius for horizontal curve of national highway in plain terrain? Assume ruling design speed 127 km per hour, minimum design speed 80 km per hour, rate of superelevation is 0.05 and coefficient of friction is 0.05. So this is the formula to calculate the ruling minimum radius, which is E plus F is equals to V square divided by 127 R ruling. So this formula is in terms of kilometers per hour. So put the given values into this formula. After calculation we get the ruling radius as 1270 meters. So here option number C is correct. Then fourth question, what is the mechanical extra widening required for a two-lane pavement of width 7 meter on a horizontal curve of radius 250 meter if the longest wheelbase of a vehicle expected on the road is 5 meter with a design speed of 70 kilometers per hour. So to find out the mechanical extra widening, the formula is NL square divided by 2R. So the mechanical widening and psychological widening is, if we add the mechanical widening and psychological widening, then we get the extra widening here. In the question, the mechanical widening is equals to NL square divided by 2R. So N is given here, which is 2-lane pavement. So N is equals to 2. Then the length is 5 meter and radius is 250 meter. After putting the given values into this formula, which is NL square divided by 2R, then we get the mechanical widening as 0 0.1 meters. So here option number C is correct. The next question, question number 5. What nature of wrapping stresses are generated in a reinforced cement concrete pavement during a summer day? So during summer day, the wrapping stresses generated in the reinforced cement concrete pavements are, so first, in the bottom fiber, the tensile stresses are generated. Okay, and in the top fibers, the compression stresses are generated. So here the option number first is correct. Tensile in bottom fiber and compression in the top fiber. The next question. Then question number 6. For a heel road with ruling gradient of 6%, what will be the compensated gradient at a curve of radius 60 meter? So to find out the compensated curve, the formula is, there are two formulas. From that two formulas, whichever the value is lesser, we take that value and we subtract that value from the ruling gradient. Okay. So to find out the compensated gradient. So the gradient, first grade compensation is, so for grade compensation, the formula is 30 plus R divided by capital R. So first formula is this 30 plus R divided by capital R. After putting the given value, which is 60 meter, R is equals to 60 meter. So this 30 plus 60 divided by 60 is equals to 1.5%. Then next, grade compensation is 75 by R percent, which is equals to 1.25%. In the given two values or in the calculated two values, 1.25% is a lesser value. So take the grade compensation as the lesser value. Then subtract the grade compensation value from the ruling gradient, then we'll get the compensated gradient. So compensated gradient is, here they want to calculate the compensated gradient. Okay, so compensated gradient is equals to ruling gradient minus grade compensation. Grade compensation formula is, first formula is 30 plus capital R divided by capital R. Second formula is 75 divided by capital R. Okay, from the two formulas, whichever the value is lesser, we take that value and subtract that value from the ruling gradient. Then we'll get the compensated gradient, which is equals to 4.75%. So here option number third is correct, which is 4.75%. The next question, which one is not a road pattern? Which one is not a road pattern? So there are different kind of road patterns. So in the option number first, block pattern, yes, block pattern is the road pattern. Star and block pattern, hexagonal pattern, all the three are the road patterns. Okay, but the diamond pattern is not a road pattern. So here last option is correct, which is diamond pattern. There are different type of road patterns. In that, first one is rectangular, block pattern, then radial or star patterns. In the radial or star, first is block, second is circular, third is grid pattern, and last one is the hexagonal pattern. Okay, so these are the patterns for the road. The next question, a road sign indicates no parking. So for no parking is mandatory sign, required sign. So here the second option is correct. So no parking is considered under the mandatory sign. So these are the different cautionary, informatory, mandatory. These are the different types of road signs, and all the three signs have a different kind of colors for border and for background. So these are the color for the border and background, and these are the shapes for the different sign. So this is the important chart. The next question, on a right angle two lane road intersection with two-way traffic, the total number of potential conflict points are, okay, total number of potential conflict points are, in the question two lane road is given, okay, and two-way traffic is given. So total number of potential conflicts are, so for different type of roads, for different lane of road, for two-way traffic, for one-way traffic, for one-way and two-way traffic, for all the different kind of traffics, the potential conflict is different. So this is the chart for potential conflict. So in the first, number of lanes are given. If road A has 2, 2 and 4 lanes, if road B has a 2, 4 and 4 lanes. Here for the number of potential conflict, three conditions are there. In the first, both roads are two-way. Second, A is one-way, B is two-way, and last, both the roads are one-way. Okay, so this is the chart. In the question, two-lane road means road is two-lane and traffic is two-way. Okay, so two-lane road and traffic is two-way. So this is two-lane here, and traffic is two-way. So for this given particular question, the potential conflicts are 24. So last option is correct here. The next question. Then question number 10, the interface treatment provided to plug in the voids of porous surface and to bond loose particles in bituminous pavement is called as. So here the interface treatment used to plug the voids of porous surface and to bond the loose particles in a bituminous pavement is nothing but a prime coat. So here third option is correct, which is prime coat. Tack coat. Tack coat is the tack coat is provided for proper binding between two layers of binder coats, and that tack coat is thin coat. Then seal coat. Seal coat is also a thin surface treatment which is used to provide a waterproof surface and provide the skid resistant surface. So the next question is, then question number 11, The type of transition curve that is generally provided on heel road. So the type of transition curve for the heel road is spiral. So your last option is correct. And the second, the cubic parabola is provided for the railway. For the heel road, the transition curve is spiral, and for the railway, the transition curve is cubic parabola. So here the last option is correct, which is spiral. Then question number 12, for list scoring and hard ground, which type of foundation is used? So the first option is raft foundation. Raft foundation is used where if we calculate the area of foundation, that area of foundation is larger than the area of plot, then we use the raft foundation, or we use the raft foundation in the black cotton soil. The next is spread foundation. The spread foundation is used in the hard ground. The next, pile foundation. Pile foundation is used in that kind of soil which is not hard enough to resist the foundation. So there we use the pile foundation. But here in the question they ask about the list scoring and hard ground. So for hard ground we prefer the sprayed foundation. Here option number second is correct. The next question. Then question number 13. Which of the following pair is not correctly matched regarding type of road surface and IRC recommended value of camber in very heavy range place? In very heavy range place, there are two ranges, heavy rainfall and light rainfall. In the question, heavy rainfall range is given. So the first type of road or first type of road is with cement concrete and high type of bituminous surface. So first is cement concrete and high type of bituminous surface. The range is in between 1 in 50 and 1 in 60. 1 in 50 for the heavy rainfall, 1 in 60 for the light rainfall. So third is correct. Second is about the thin bituminous surface. So for thin bituminous surface, first range is 1 in 40 and second is 1 in 50. So for heavy rainfall, 1 in 40 is the correct range. But here the 1 in 65 is not correct. So in the question they ask about not correctly matched. So option number 4 is not correct here. Then we'll see the remaining option. Next option is waterbound macadam and gravel pavement. For waterbound macadam and gravel pavement, the range for heavy is 1 in 33 and for the low 1 in 40. So this first is also correct. Then last is earth surface, which is 1 in 25. This is also correct. 1 in 25 for heavy rainfall and 1 in 33 for light rainfall. So this is also correct. So here the option number fourth is correct, which is thin bituminous surface. The next question is, then question number 14, the maximum super elevation on heel roads should not exceed. So there are different kind of super elevations for different kind of road or different kind of plane conditions. So first condition is for plain and rolling terrain. So for plain and rolling terrain, the super elevation is 7%. For hilly roads, the super elevation is 10%. Last, for urban road, the super elevation is 4%. So here option number 4 is correct, which is 10%. 10% is the maximum super elevation for the hilly roads. The next is, an engineering survey is proposed in a highway alignment project. The survey include following stages. So for engineering survey, there are 4 stages. In that, first one is map study, second is reconnaissance, third is preliminary survey, and last one is final location and detail survey. So by arranging these 4 steps, third is first here. So this is first, reconnaissance is second, preliminary is third, and final location is fourth. So here option number 1 is correct as per the sequence. The next question. Question number 16. Remaining questions are one-liner questions. So in that, first one is widening of roads on hilly region is done. So widening of roads on hilly region is done on inner side. So option number second is correct here. The next question. The instrument used for measuring the spot speed, that instrument is inoscope. So option number C is correct. The next question. The rate of rise or fall of formation level of a road along its alignment is called as, so the rate of rise or fall of formation level of road along the alignment is gradient. Option number C is correct here. The next, temperature stresses in concrete pavement may cause the slab to crack. If pavement slab cools uniformly, then the crack will develop at the following location of slab. If the temperature stresses in the concrete pavement may causes the slab to crack. If pavement slab is cools uniformly, then that cracks is developed at the center of the slab. So your option number second is correct. Then the last question from this test series, which is, which one of the following method is used in the design of rigid pavement? So the design of rigid pavement, the method is Westergaard method. So here option number C is correct. So this is all about the test series 3, which is based on highway engineering, and thank you for watching. Then question number 1, for 1 cubic meter of concrete, which is 1:2:4, the number of cement bag required is. To calculate the cement bag, first we know about the weight concrete volume, and second is dry concrete volume. So here the volume of weight concrete is 1 meter cube, and dry concrete volume is weight concrete volume into 1.54. So here the dry concrete volume is 1 into 1.54, which is equals to 1.54 meter cube. To calculate the cement bag, first we know about the volume of cement required. So third step is volume of cement required. So here how to calculate the volume of cement required? Here the given ratio is 1:2:4. So here 1 is related to cement, second is related to sand, and third is related to aggregate. Okay, so to calculate the volume of cement, first take 1 in the numerator and 1 plus 2 plus 4 remaining ratio in the denominator. Then multiply with the dry concrete volume, which is 1.54. So here the volume of cement required is 0.22 meter cube. Then fourth step is to calculate the weight of cement required. The formula is volume of cement into density of cement. So volume of cement is 0.22 into density of cement is 1440. Okay, so the weight of cement is 316.8 kg. The next last step is to calculate the number of cement bags. So one cement bag is of 50 kg. So total cement is 316.8. So divided by 50. So you will get the total number of cement bags, which is 3.6.336 bags. So these bags are nearly equal to 7. So here the value is given in the point. So here the correct option is last, which is 6.51. The next question. Then second question, the document which describes the materials and workmanship required for the development but not include cost quality is known as. So here the document which describes the material and workmanship but not include the cost and quantity. So that document is specification. So here option number 2 is correct. The next question number 3, the sum per day for each day of daily due to the reason that the contractor not completing the work in the scheduled time. Okay, here not completing the work in the scheduled time or also within the extended time if allowed by the authorities on valid ground due to charge is leveled on him is known as. So here not completing the work within the scheduled time or within the extended time, that is nothing but a liquidated damage, and liquidated damage is also known as a certain damage. So here option number 3, both 1 and 2 is correct. Option number C is correct here. And the unliquidated damage is Okay. There is one more term which is unliquidated damage. Unliquidated damage is nothing but the actual damage of work. Actual damage of work. So for this question, the option number C is correct, which is both 1 and 2. The next question. Question number 4. For brickwork, no deduction is made for the area of opening up to. So in case of brickwork, the area of opening is up to 0.1 square meter. Up to this opening, no deduction is taken in the brickwork. Here the option number 1 is correct. The next question. Question number 5. For obtaining the environmental lead for sandy track, lead is multiplied by. Okay, lead is nothing but a horizontal displacement of the excavated material. And in case of sandy track, the lead is multiplied by 1.4. Then second condition is metal track. In metal track, the lead is multiplied by 1. Third is cards track. In cards track, the lead is multiplied by 1.1. Here for the sandy track, the lead is multiplied by 1.4. So here point is missing. So here 1 point, option first is 1.1, second is 1. First is 1.2, second is 1.1, third is 1.3, and last one is 1.4. So here option number 4 is correct. The next question. Question number 6. Tender document consists of which of the following part? So for the tender document, here first option is schedule of items of work. So schedule of item of work is considered in case of document of tender. Location of work is also consist the tender document part. So here the both option first and second is correct. So option number C is correct here. Next question. Question number 7. Pick up the correct statement from the following. In that first statement is painting is measured in square meter. So first is correct because in case of painting we consider the length and width of the wall. So here length and width, two dimensions are there. So the painting is measured in the square meter. First one is correct. Second is excavation is measured in square meter. In case of excavation, length, width and depth, all the three dimensions are required. So the excavation is measured in cubic meter. So second one is wrong. But the surface excavation is measured in square meter. Surface excavation is nothing but length is given, width is given, but depth is very less, which is less than 30 centimeter. So this condition is surface excavation, and surface excavation is measured in square meter, and only the excavation which has a more depth than the 30 centimeter, that is measured in cubic meter. The next option is construction joint is measured in square meter. So this is wrong. Third option is wrong because construction joints, that is expansion joint, contraction joints, all are measured in running meter or in meter scale. Then last one is plastering is measured in square meter. Last one is also correct because for painting and for plastering same surface is there. So for painting and plastering the measured unit is square meter. So in the option first and 4 is correct. So first and 4 is given in the last option. So the last option 1 and 4 only are the correct. The next question. Question number 8. The contractor puts up higher rates for certain items and lower rates for other items so that the total amount of tender remains practically unaffected. Here higher rates for certain items and lower rates for the other items to keep the tender practically unaffected. That tender is known as unbalanced tender. So second option is correct here. The next question. Question number 9. The carpet area of residential building is generally of its plinth area. For residential building, first the carpet area for office building, carpet area for office building is 60 to 75% of plinth area, and in case of residential building, the area is 50 to 65% of plinth area. So here second option is correct, which is 50% to 65% of its plinth area. Then next question. Question number 10. In the construction industry, contractor's profit is included in. So contractor's profit is included in unit rate of atom. First option is correct, because in case of unit rate atoms, here they consider the price of each individual material by their own. So that's why here in case of unit rate atoms, the contractor profit is gain in the construction industry. The next question. Question number 11 dash dash is the technique of estimating or determining the fair price or the value of property such as building, a factory, other engineering structures of various types. So this technique is nothing but a valuation. In case of valuation, the estimating and determining of fair prices and the value of property of building, factory and other engineering structures of the various types are included. So here option number C is correct. The next question, question number 12. Generally the rent of building is, so generally the rent of building is 5 to 10% of valuated cost. Here second option is correct. Then question number 13. Pick up the correct statement from the following. So first statement is pointing is measured in square meter. Pointing is a similar procedure like plastering. In case of pointing, we just feel the joints between the bricks, and in case of plastering, we feel the whole area of the brick or the brick masonry. Pointing is measured in the square meter. This option is correct. Second, plastering is in square meter. Second is also correct, and glazing is also measured in square meter. All of the above are correct. So here last option is correct. The next question, question number 14. What is the unit of measuring cornice? So for measuring a cornice, first we know about the cornice. So cornice is an architectural member which is in between the wall and roof. Cornice is architectural member which is in between the wall and roof. So cornice is measured in running meter. So last option is correct here. Then last question, question number 15. The yearly installment of sinking fund for a building costing of 5 lakh. So yearly installment is 5 lakh. So this yearly installment is nothing but a sinking fund. So yes is equals to 5 lakh, which is sinking fund. Then next, whose future life is 20 years, means number of years n equals to 20. Then take sinking fund factor for 20 years is 5%. So 5% is nothing but rate of interest, which is I, and I equals to 5%. So 5% is nothing but 0.05. So the formula to calculate this yearly installment of sinking fund. So to calculate the yearly installment of sinking fund, annual sinking fund is nothing but annual sinking fund is equals to IC into S. So this IC is equals to I divided by 1 plus I raised to n minus 1 into S. So after putting the given values into this formula, here S is equals to 5 lakh divided by 1 plus 0.05 raised to 20 minus 1. After calculation, you get the answer which is 15100. So here this option is given in the third option, which is rupees 15100. So the yearly installment of sinking fund is option number third is correct. First question, what must be the minimum grade of concrete to be used for a reinforced concrete, means RCC, structural element which is exposed to extreme exposure condition? There are 5 exposure condition. First one is mild, second is moderate, third one is severe, next is very severe, and last condition is extreme condition. In case of mild condition, in case of mild, M20 grade is used. In case of moderate, M25. In case of severe, M30. In case of very severe, M35 grade is used. And in case of extreme condition, M40 grade is used. So here the M40 is given in the third option. So this third option is correct here. Then these are the few tables for more information. So in the question they ask about only RCC, but these are the grade values for PCC. Then the nominal cover, then cement content, minimum cement content and minimum water cement ratio for PCC and for RCC. Okay, then next question. Then second question. Consider the following strength of concrete: cube strength, cylinder, split tensile and modulus of rupture. Correct sequence in increasing order of these strength. So for this there is one equation which is cylinder strength is equals to 0.85 times of cube strength. Okay, so here by observing this equation, we know that the cube strength is larger than the cylinder strength. Okay, so here for increasing order, first cylindrical strength come and then cubic strength come. But in the first and second option, first they mention the cube strength, then next cube cylinder strength. Means option number first and second is wrong. But option number third and fourth, B and A is in correct arrangement. Means cylinder is first and then cube strength is latter as per the increasing order. Then in case of split tensile strength and modulus of rupture, split tensile strength gives lesser strength. Okay, always remember that split tensile strength gives lesser strength. So here C is first, then D, B and A. So this is the correct order. So here option number third is correct for the increasing order of strength. Then next question. Then question number third, the nominal mix corresponding to M15 grade concrete. So for nominal mixes there is one table and that table is first the values start from M5, M5 then M7.5, M10, M15, M20 and M25. Okay, there is one trick to remember the nominal mixes here. First write 1 for each grade, then next write from 5 in decreasing order. Here 5, then 4, 3, 2, then 1.5 and 1. Okay, then double the value like this. Right here 10, 5 is double, 8, 3 2s are 6, 2 2s are 4, 1.5 into 2, 3 and here 1 into 2 which is equals to 2. So these are the proportions for the grade of concrete. So here they ask about the M15 grade. So for M15 the proportion is 1:2:4. So here option number first is correct. The next question. Fourth question. The maximum spacing of shear reinforcement as vertical stirrups measured along the axis of a reinforced concrete beam of width 300 mm and effective depth 500 mm with space of 6 meter is. So for shear reinforcement there are two conditions. First condition is shear reinforcement should not be more than 0.75 d. Okay, d is depth. And if this shear reinforcement is more than 0.75 d, then take the shear reinforcement as 300 mm. Okay, spacing of shear reinforcement as 300 mm. This is all about the spacing of shear reinforcement. So here the depth given is 500 mm. So we'll put the given value into the formula. So the spacing of shear reinforcement is shear reinforcement should not be more than 0.75 D. So first we'll put in this equation. 0.75 into D is 500. So this value is nearly equals to 375 mm, but this value is more than the shear reinforcement value, which is 300 mm, more than this. Okay, so because of that, we'll take the spacing of shear reinforcement as 300 mm, and which is given in the first option. So here first option is correct. The next question number 5. Question number 5 is the minimum eccentricity to be considered for an axially loaded RCC column of size 400 mm by 400 mm with unsupported length 5 meter. So for minimum eccentricity, the formula is unsupported length divided by 500 plus the size of beam divided by 30. So here unsupported length given in the meter, so convert into mm. 5000 mm divided by 500 plus 400 divided by 30. So this value is nearly equals to 23.3 mm. So this is the minimum eccentricity. So here third option is correct. The next question. Question number 6. The minimum stripping time of soffit formwork to beams props to be refixed immediately after removal of formwork. So for this, the minimum stripping time is 7 days. Minimum stripping time is 7 days. So here the 7 days is mentioned in the third option. So third option is correct here. But there are remaining values. That remaining values is first the vertical formwork for column, beam and wall. The timing is 16 to 24 hours. Then second one is for slab. Props are immediately fixed after removal of formwork. The timing is 3 days. Then third, here soffit of slab. Okay, soffit of slab. Then next is soffit of beam, 7 days. Then fourth one, here the props are to be refixed immediately after removal of formwork. So then the timing between props for slab, props to slab. So in that the condition is when span is 4.5 meter or less than that, then the timing is 7 days. If span is more than 4.5 meter, then 14 days. Then next one, fifth, props to, the slab is mentioned, then props to beam. If span is more than 6 meter or span is equals to 6 meter, less than or equal to 6 meter, then 14 days. And if span is more than 6 meter, then 21 days. Okay, these are the stripping times. So this is less or equal, this is for more, this is for less or equal, this is for more. Here the third option is correct. The next question. Then question number 7. The design bond stress 1.5 Newton per mm square is assumed, then the development length of Fe 500 HYST bar nominal diameter is 12 mm, which is fully in tension will be. So for development length, the formula is LD is equals to 5.87 Fy divided by 4 tau BD. So this is what the formula for the development length. Here the given values are phi is equals to 12 meter, then tau BD is 1.5 Newton per mm square. Here the tau BD in case of tension is increased by 60%, and in case of compression this increased by 40%. 60% means 100 by 60 and here 100 by 40. The value 100 by 40, the values are equals to here 1 by 6 and this value is nothing but 2.5. So these are the values for the multiplying factor for this tau BD. Then the next given value is Fy, which is equals to 500. So put the given value into the formula. LD is equals to 5 value is 12 into 0.87 into 500 divided by 4 into 1.6, because the tension condition is mentioned in the questions. For tension 60% value is increased, which is 1.6 into 1.5, and the calculation, after calculation we get 544 mm, and this is mentioned 544 mm is mentioned in the option number first. So your first option is correct. Then next question. Then question number 8. For M20 grade of concrete, modular ratio would be. So for modular ratio, the formula is 280 divided by 3 into sigma CBC. For this sigma CBC, this is the table. This is the sigma CBC mean permissible stresses in compression for bending, and these are the direct stresses. So bending stresses are sigma CBC and value for M20 grade is 7. So here sigma CBC is 7. So put the 7 into this formula, 280 divided by 3 into 7, and this modular ratio is equals to 13.13. So here the option number 1 is correct, which is 13.33. The next question. Then question number 9. At what stress does the flexure crack appears in the RCC beam made of M25 grade concrete? So for flexure crack appears in the RCC beam, the stress is, formula for that, FCD is equals to 0.7 square root of FCK. Okay, so here FCK is equals to 25. So put the 25 into the formula. So we get 3.5 as a 3.5 MPa as a stress which does the first flexure crack appears in the RCC beam. So here B option is correct. The next question. Then question number 10. In limit state design method, the moment of resistance for a balanced section using M20 grade concrete and HYST steel of grade Fe415 is given by this MOR is moment of resistance equals to KBD square. What is the value of K here? So the value of K here they ask. So the formulas for the moment of resistance are so first we'll discuss about the formulas and then we'll solve the numerical. So first formula is for Fe250, second for Fe415, and third formula is for Fe500. So first formula is moment of resistance equals to 0.148 FCK BD square. Then second, moment of resistance formula for Fe415 is 0.138 FCK BD square. Then last formula for Fe500, moment of resistance is equals to 0.133 FCK BD square. Okay, so here we use this Fe415, which is moment of resistance equals to 0.138 FCK BD square. So here this K value is equals to 0.138 FCK. Okay, so I'll write this formula here. MOR, moment of resistance for Fe415 is equals to 0.138 FCK BD square, and in the question they ask MOR equals to K BD square and they ask about the value of K here. Okay, so for K we take 0.138 FCK, and this FCK value is mentioned, which is M20. So here FCK is equals to 20. So 1.138 into 20 is equals to 2.76. So this is the value for the K, and here option number 2 is correct. The next question, question number 11. What is the minimum area of tension reinforcement in beam when Fe415 is used? So for Fe415, the minimum area of tension reinforcement PT is equals to 0.85 into 100 divided by Fy. So 0.85 into 100 divided by 415 is nearly equals to 0.2%. So here option number D is correct. The next question. Then question number 12. The minimum strain at failure in tension steel having yield stress Fy to 50 MPa, Young's modulus given is ES equals to 200 GPa. The limit state method of design is, as per the limit state of design is, so formula for that is sigma S is equals to 0.87 Fy divided by ES plus 0.002. So here Fy given is 0.87 into 250 MPa. So convert this MPa into Pascal, which is 10 raised to 6. Okay. Then next ES is equals to 200 into 10 raised to 9 to convert the gigapascal into Pascal. So after plus 0.002. So after calculation you get the sigma S, which is minimum strain at failure in tension steel, is 0.0030. So here first option is correct. The next question. Then question number 14. The effective width B of flange of continuous T-beam in a floor system is given by BF is equals to L0 by 6 plus BW plus 6 DF, where this L0 represents. So for this L0 is nothing but distance between the point of contraflexure in the span. So your first option is correct. The next question. Question number 14. If Cu and Fy are cube compressive strength of concrete and yield stress of steel respectively, Es is the modulus of elasticity of steel for all grades of concrete. The ultimate flexure strength in concrete can be taken as, so ultimate flexure strain in concrete is third option, which is 0.0035. The next question. The assumption that the plane section normal before bending remains normal after bending is used. So this is question number 15. The assumption that the plane section normal before bending remain normal after bending. The assumption is in both the working state and limit state design. So third option is correct here. Then question number 16. Design strength for M25 concrete in direct compression, bending compression, flexural tension as per the LSM limit state method respectively. So the formulas for these kind of compressions and tensions are: first, for the direct compression, formula is 0.4 into FCK. Then second formula is for bending compression, which is equals to 0.45 into FCK. Then next third formula is for flexural tension, which is equals to 0.7 square root of FCK. 0.7 into square root of FCK. So while putting the given values into this question, so we get this 0.4 into 25, which is equals to 10 MPa. Then 0.45 into 25, which is equals to 11.15 MPa. Then last one is 0.7 into square root of FCK, which is 0.7 into 5, which is 3.5 MPa. Okay, so all the three options are present in the first option. So here first option is correct, which is 10 MPa direct compression, 11.15 MPa, 11.15 MPa bending compression, and 3.5 MPa is a flexural tension as per the limit state method. The next question. Question number 17. The anchorage value of hook is assumed 4 times the diameter of bar if the angle of the bend is. So for 4 times of diameter, the angle of bend is 45 degree. For 8.5, angle of bend is 90 degree. For 12.5, angle of bend is 135 degree. For 16.5, the angle of bend is 180 degree. So here 45 is mentioned in third option. So for this question, third option is correct. The next question, question number 18. At which condition splicing of reinforcement bar in RCC beam is required? So for splicing of reinforcement in the RCC beam, the bending moment should be less than the half of maximum bending moment on the beam. So here the bending moment should be less than, and that mentioned in the second option. So the second option is correct for this question. The next question number 19. The maximum deflection due to load in RCC beam in a building is limited to. So for maximum deflection, the value is related to span of that beam. So here the span by 250 is the maximum deflection due to the load in case of RCC beam. The second option is correct. The next question, last question, question number 20. In a simply supported slab, alternate bars are curled at. So curled at 1/7 of the span or 0.15 L of the span. Okay, these are the two values. In the question 1/7 of span is mentioned. So third option is correct here. So this is about the test. First question. The permissible bending stress in slab base of steel column for all grades of steel is limited to. So this is the constant value which is for the permissible bending stress in slab base. Okay, in slab base, and that value is limited to 185 Newton per mm square. Here this is square. So for this question, the first option is correct. There are some remaining terms which is related to the permissible stresses. In that, first one is axial stress. For axial stress, the permissible stress value is 0.6 Fy. Fy is yield strength of steel. Then second one is bending stress. Value for bending stress is 0.66 Fy for permissible stress. Then next is average shear stress. Value is 0.4 Fy. Next one is maximum shear stress. Value is 0.45 Fy. Then last one is bearing stress, and the permissible value is 0.75 Fy. Okay, so these are the remaining terms related to the permissible stresses, and about the slab base, the value is 185 Newton per mm square. Then next question. Then question number 2. The maximum allowable vertical deflection under live load for cantilever member supporting brittle cladding in the industrial building. So for vertical deflection, here we consider two conditions. First one is cantilever beam, or cantilever member. Second one is simply supported member. Okay, so they in the case of cantilever and simply supported, the supports are different. So that's why the deflection in case of both beam is different. So for that, here we consider two conditions. First one is elastic cladding. First one is elastic cladding. In case of elastic cladding, the deflection is span by 120 if the beam is cantilever, and if the beam is simply supported, then the elastic cladding deflection is span by 240. If brittle cladding is present, the vertical deflection in case of cantilever is span by 150, and in case of simply supported, the vertical deflection is span by 300. Here in case of simply supported beam, there is one condition extra than the cantilever beam, which is maximum deflection in case of simply supported beam is less than L by 325. L is the span, and this is the general condition for the vertical deflection in case of simply supported beam. As per the question, they ask about the brittle cladding in the cantilever beam. So for the brittle cladding in cantilever beam, vertical deflection is span by 150. So here last option is correct, which is span by 150. The next question. Third question. Select incorrect statement from the following. So we'll see each option one by one. So first one is purlin is subjected to biaxial bending. So first option is correct, because if in case of any construction the flat is or the roof is flat, then uniaxial bending happen. But in case of truss, the roof is inclined or sloping. So that's why here biaxial bending happen. In case of sloping roof, biaxial bending happen. Okay, the next option is the span of purlin is center to center of truss. Purlin is located at the panel point of the truss. Yes, this is correct, because purlin span is from center to center of truss and purlin is located at the panel point of the truss. So this is how the structure of the truss. Okay, I'll draw the structure here. This is how the structure of a truss. These two are the principal rafters. And here at the last there is also principal rafter. On the principal rafter we place the purlin. Here. Okay, so this is how the purlin, and to support the purlin, cleats are provided here. Okay, and in the remaining part here common rafters are present. So here the second option is correct. Then third option is purlin runs perpendicular to truss. Yes, for the truss the purlins are perpendicular. Third option is also correct. Then last option is purlin is designed as a tension member. Purlin is not designed as a tension or compression member, but the purlin is designed as a bending or flexural member, and here the bending or flexure is biaxial. So last option is incorrect. So for this question the fourth option is correct. Here. The next question. Question number 4. If D is the depth of wave, T is the thickness of wave of a plate girder such that, this is the given condition, and for this given condition we know about the stiffness provided, which kind of stiffness is provided for this condition. So there are different conditions for stiffness in case of plate girder. First condition is if D by TW is less than 67 epsilon, then this plate girder is considered as ordinary beam. Second condition is D by TW is less than or equal to 85 epsilon. Then no need of stiffness here. The third one is d by tw is greater than 85 epsilon but less than or equal to 200 epsilon. Fourth condition is if d by tw is greater than 200 epsilon but less than or equal to 250 epsilon. Fifth condition is if the d by tw is greater than 250 epsilon but less than 400 epsilon. These are the conditions. So in that for this condition only vertical stiffness are provided. Only vertical stiffness are provided. For the next condition, vertical stiffener plus first horizontal stiffness are provided at point 2D. For this condition, vertical stiffness plus first horizontal stiffener at point 2D and plus second horizontal stiffener at 0.5D are provided here. Then last condition is if this d by tw is greater than 400 epsilon, then here in this case increase the thickness of wave. Increase the thickness of wave. Okay, so for this question, the third option is correct here, that end bearing stiffness, intermediate transverse stiffness, longitudinal stiffness at point 2D from compressive phase at neutral axis are needed. So your third option is correct. The next question. Then fifth question. A steel rod of 20 mm diameter is used as a tie member in the roof bracing system and may be subjected to permissible stress due to wind load. What is the maximum permissible length? Permissible length means L effective. So to find out the L effective, first we know about the lambda value, then K value. Lambda is nothing but a slenderness ratio, and K is radius of gyration. So first, as per the tension member, there is one chart for the slenderness ratio. In that first condition is due to reversal of loading except wind and seismic load, the value for the slenderness ratio is 180. Then second, due to wind and earthquake load, the value of slenderness ratio is 350. And last one is if that member is permanently subjected to tension, then the value of lambda is 400. Lambda is equals to L effective by K. K is the radius of gyration and K is equals to square root of I by A. I is the moment of inertia, A is the area. For moment of inertia, here the diameter is given, means circular section is given. Circular cross section is given. So for that the moment of inertia is pi by 64 d raised to 4 divided by area is pi by 4 d square. After putting the diameter value into this, we get the radius of gyration as 5 mm and the lambda value is 350 here because due to the wind load, reversal of stress is due to the wind load, so here the lambda is 350. So L effective is equals to lambda into radius of gyration, which is 350 into 5, and the answer is 1750, which is in the first option. So first option is correct here. Then next, so before the next question, to solve these kind of questions, you know about the table of the slenderness ratio, you know about the values of the slenderness ratio, then you know about the formula for the slenderness ratio, radius of gyration formula, then moment of inertia formula. So for this particular question, you require 5 to 6 formulas and one chart to solve this question. Then next question. Then question number 6. For simply supported beam, the maximum permitted deflection is as per the IS 800-2007. In the second question, we discuss about the vertical deflections in case of cantilever beam and simply supported beam. And in that question, I mentioned that in case of simply supported beam, the maximum deflection should be less than 1 by 325 of span. Okay, but this value is regarding the IS 800 1984 and this is the old code, and the new version of this code is IS 800 2000, and in this code the value of maximum permitted deflection given is 1 by 300 of the span. So you can correct the value of this deflection from the second question. So for this question, the value for the permitted maximum deflection is 1 by 300 of the span. Second option is correct here. The next question, question number 7. For maximum value of effective slenderness ratio as per IS 800 for a tension member in a reversal of direct stresses occurs due to the loads other than wind and seismic load. In the fifth question, we discuss the chart of the tension member. In that, the first value, which is other than the wind and seismic load, the slenderness ratio for this condition is 180. So for the 180 here, last option is correct. The next question. Then question number 8. The shape factor for standard roll beam section. So to know about the standard roll beam section shape factor, first we know about that the roll section is of I or H shape, and for I and H shape the shape factor is 1.1 to 1.2. So first option is correct. So here we discuss about the remaining shapes. So in that, first one is rectangle. There is one trick to remember this shape factor. The trick is, first there are 6 shapes. First one is rectangle, so remember here R. Second one is circle, C, RC, then DT, and then IT. Okay, these are the shapes. First one is rectangle, second one is circle, third is diamond, fourth one is triangular, fifth one is I or H beam, and last one is T. The value for the rectangle is 1.5, for circle 1.697, for diamond 2, and for triangle 2.34. For the first 4, the numbers are in an increasing order, and then 2 values are for I and H section, which is 1.10 and 1.20, and the remaining for the T section, the value is 1.90 to 1.95. Okay, so this is about the shape factor. If you know about the extra points related to the shape factor, the formula for shape factor is MP by My, or you can elaborate this formula as A by 2 into Y1 bar plus Y2 bar divided by I by Y max. I by Y max is nothing but section modulus. Okay, so this is how you can discuss your things from one question to another question. The next question is, then question number 9. On increasing the quantity of carbon in steel, one of the following decreases. Okay, so let's discuss what happens when the quantity of carbon is increases. So first thing is, if carbon content increases, then the strength of the steel increases. Strength increases. Second, if you increase the quantity of carbon in a steel, then the carbon, because of the carbon, the steel goes from pure carbon to impure carbon. Steel goes from pure carbon to impure carbon, or impure steel. For example, the wrought iron has a less carbon content, so it considered as a pure steel, but the pig iron is with a high carbon content, so it considered as a impure carbon steel. Then third one is, if this quantity of carbon increases, then elongation decreases, and if this elongation decreases, then the ductility property decreases, because ductility has the ability to make any steel into the wire, so it has a more tensile in nature. So this ductility also reduces here, and ductility is also known as tensility. So tensility is given in the last option, so here last option is correct. The next question, so this question is similar here, that if carbon content of steel is increased, which parameter of steel is reduced. Their tensility is given, and here in this question the ductility is given. So second option is correct here.